right, lesson 47 is equivalent fractions, which we've been talking about equivalent fractions since like third grade. And we've done it a lot in the last few lessons, just talking about them, but we're just going to go backwards a little bit and remember what they actually are and how you get them so that you can go back and forth to smaller versions versus larger versions of the same fraction equivalents so that it's easy to visualize it in your mind. And one of their standards for this one is to know how to show an equivalent fraction in a model. So let's take a look at this model that they have on the first one, which is 2, 6. So of course, we have a rectangle that is split into 6 equal pieces, and 2 of them are shaded. And so this is a model of 2 sixths. So the next step would be to take the same rectangle, and this time we are going to divide that rectangle in half down the middle. It doesn't matter which way you divide it. And when you divide the rectangle in half, you're actually multiplying the amount of pieces by 2, right? Because now instead of 1 piece, we have 2. 1 times 2 is 2. And we now, instead of 6 pieces, we have 12 pieces. So we've really multiplied. So we had 2 sixths. And now we have, it's equal to how many twelfths? We have 12 on the bottom. That's our denominator. That's how many pieces our whole is cut into, and the amount that are shaded is 4. So 2 6 and 4 twelfths are equal, and here are our models to show that that is equal. And really, essentially, what we're doing is multiplying the numerator and the denominator by the same number. Because remember, when you're making an equivalent fraction, you just have to multiply the top and the bottom, the numerator and the denominator, by the same fraction. In this case, what are we multiplying it by? 2 times what makes 4? We split each piece into 2 equal pieces. And when we do the multiply the top, we have to multiply the bottom by the same number. So 2 times 2 is 4, 6 times 2 is 12. Our equivalent fraction is 4 twelfths. So the same could be said. We have the same fraction model, same rectangle, but this time, instead of cutting it into 6 equal pieces, we're cutting it into 3 equal pieces. And I'm going to actually go up to this one and show you that this could also be split into 3 equal pieces like that. So if you go straight down, they're in the same line. I can just even go right down, right? So this, and this are all equivalent models of the same amount. They're just written as different fractions, equivalent fractions. So this time we had 2 sixths, right? I'm going to put 2 sixths right here. And this time we took the line off. So we took out the divider, which really means we divided our piece by 2. So we took 2 pieces and split it into 2 parts. And so we only have 1 in each part. Okay, so I don't know if that makes sense, but so 2 6 dividing the top and the bottom by 2 makes 1/3, right? Dividing the top and the bottom. It does not work with addition and subtraction, only multiplication and division. So what you do to the numerator, you have to do to the denominator. But we're drawing models. So let's take a look. It says use models to write 2 equivalent fractions. So the first thing we want to do is make a model of 2 fourths, right? I'm trying my best to make a, just gotta go quick, a rectangle. Okay, so 2 fourths. So we're going to split it into 4 equal pieces because that's what the denominator says, right? Ish, equal-ish. All right, so one way we could do that is do this thing that they did right here by taking it, and I'm going to make it a different color. Drawing a line down the middle. I know those pieces aren't equal. So now, instead of let me put a stamp, I had 2 fourths, right? And now I have 1, 2, 3, 4 out of how many pieces altogether? 5, 6, 7, 8. So now my equivalent fraction is 4/8. Or if I wanted to I'm going to draw the model again. So we have 2/4. I'm going to, let's see, how about this? Split my thing now into just 2 equal pieces, right? And we still have these 2 that are shaded. And so this section is still shaded. All right, so another equivalent fraction, if we were to say divide that by 2, it is 1/2. You know that 2/4 and 1/2 are equivalent, and 4/8 because the top is half of the bottom. So halves are easy. Let's look at 4/6. So I'm gonna draw my, go quick, rectangle and split it into 6 equal parts. So I'm gonna split it down the middle, and then each side is gonna be 3. For a total of 6. And get my stamp, I'll just do X's. So 4, 1, 2, 3, 4 of those are shaded in. All right, and now this time we're gonna do what they did and draw a line down the middle. So now instead of, I had 6, multiplying that by 2, I now have 12 equal pieces. And how many are still shaded in? 1, 2, 3, 4, 5, 6, 7, 8, which is the same as multiplying the 4 by 2 and the 6 by 2, right? To get 8/12. All right, I'm going to take another color. I'm going to use that same model. Let's just outline it again. And this time, let's see, how many equal pieces? What could I divide it by to keep my, I'm gonna for sure have a division bar here. And then I have 4 in this spot, 1, 2, 3, 4. So 1, 2, 3, 4, 1, 2, 3, 4. That means I can divide it here. Okay, so now I have 1, 2, 3 equal pieces. And how many are filled in? 1, 2 of them are filled in, 2/3. Okay, so really what we did is took 4/6. And in order to get the 8/12, we multiplied it on the top and bottom by 2, right? And to get the 2/3, we divided by 2. So 4 divided by 2 is 2. And 6 divided by 2 is 3. So to get an equivalent fraction, we either multiplied by 2 or divided by 2. It works with any number, not just 2. But for this lesson, we're just using 2. All right, let me get my mouse and go on to the next page with you, which means I have to clear. There we go. All right, so use this model to write an equivalent fraction. So we see that they wrote a fraction for the dark bars here, right? 1, 2, 3, 4, 5, and 6 equal pieces, and 4 of them are colored in. So they're saying that if we took each of those equal pieces and divided it, it's just a matter of like seeing where would be a good division spot. So they're dividing it this way, which really, if you see that 4 and 6 are both even numbers, right? They're not odd numbers, they're even numbers. And so even numbers can always be divided by 2. So if you have a fraction that has even numbers on the top and the bottom, you know that they can be divided by 2. So 4 divided by 2 is 2 over here. 6 divided by 2 is 3. And so 2/3 is an equivalent fraction to 4/6 because they both can be divided by 2. Now, looking at 3/4, it can't be divided by 2. 3 cannot be divided by 2. 3 is a prime number. It only has 3 in itself, so 3/4 really can't be divided anymore. If you have a prime number as a numerator of your or a denominator in any of the spots in your fraction, it cannot be, it's called reduced. You cannot find an equivalent fraction that has smaller numbers in it, because if you think about it, prime numbers, you know, numbers that only have themselves and 1 as factors, we talked about that a little bit towards the end of our time together, they can't be divided by anything. So we have a prime number, 3 is a prime number on the top. So we cannot divide that fraction and make it any smaller of those pieces. So we're going to multiply it. So watch. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So there's 12 rows. So 1, 2, 4, 5, 6. I'm going to divide it in half. Right? So now I don't have 4 pieces, because if you looked at the dark lines, there were 4 lines. Now I split each of those long pieces in half. The other page we were dividing it in half this way. This one's dividing it in half this way. So now we have 1, 2, 3, 4, 5, 6, 7, 8 pieces. And we still have 1, 2, 3, 4, 5, 6 of them are colored in. And if you notice, 3 times 2 equals 6, and 4 times 2 equals 8. All right, so now you can see it with a model and how and why they're equal. Let's take a look at whether the fractions of here are equivalent. They're not asking you greater than, less than, or equal. They're just saying, are they equal or are they not equal? So really, if you cannot multiply one by anything to get the other one, they're not really equal. So let's take a look at 8/10 and 4/5. So we divide 8/10 by the same number, top and bottom, in order to get 4/5? Well, what do you divide 8 by to get 4? You divide it in half, right? Divided by 2. So 8 divided by 2 is 4. Is 10 divided by 2 5? Yes, it is. So these are equal fractions. Let's try this one. 1/2. So can we multiply anything by, well, let's see, 1. What do we multiply it by to get to 7? Ooh, times 7, 1 times 7. So is 7 the same number that we multiply 2 by to get 12? 2 times 7 would be 14. So no, these are not equal. The way we do that is a equal sign with a slash through it, not equal. All right, so 3, can we multiply 3 by anything to get 8? No. What do we multiply 4 by to get 12? 4 times 3 equals 12, right? 3 times 3 would be 9. So nope, not equal. All right, you do the rest of them and see if you can figure them out. I'll do one of the word problems with you. All right, Jamal finished 5/6 of his homework. Margaret finished 3/4 of her homework. Steve finished 10/12 of his homework. Which 2 students finished the same amount of homework? Well, let's see. So 5/6, 3/4, and 10/12. All right, I'm just going to start here. What do you multiply 4 by to get to 12? 4 times 3 is 12. Is 3 times 3 10? No. 3 times 3 is 9. So these 2 are not equal. Let's go to these 2. 5 divided by anything make 3? No. So that's going to be too hard. Let's go here for this one to this one. 5 times 2 is 12, or sorry, 10. 5 times 2 is 10, and 6 times 2 is 12. So this one and this one are equal, which means which 2 students finished the same amount of work? So we actually have to write their names. So who did 5/6? Jamal and Steve. Right? Perfect. All right, you do the other one. Okay? All right. If you need help, remember to come see me, and hopefully I'll remember to open it. All right.